Welcome to Introduction to Data Management course, Lesson 1. This lesson covers metadata management capability. After this lesson, you will be able to understand fundamental concepts, people, process and technology aspects of metadata management. Understanding of basic concepts is a very first step in every learning process. So, let's start with data element, as the basic concept in metadata management.
A data element refers to a unit of data for which the definition, identification, representation, and permissible values are specified by means of a set of attributes.
Even in small organizations, there is a huge number of data elements, and not all of them are equally important. Those which are of special interest for the organization are called critical data elements. Critical data element is the data element that is critical to success in a specific business area or business process. It is very important to tag critical data elements, because it is not effective, neither possible, to manage all data elements on the same way, due to resource limitations.
What is the criteria for one data element to become critical? One data element can be considered as critical if refers to 1. Business facts that are deemed critical to the organization. 2. Support critical business processes across an organization and its components. 3. Data used to derive values that appear in key reports. 4. Unique identifiers of things important to the business, for instance, customer ID.
This criteria list is not all-inclusive, as there are many other examples. Any data element that is required for the execution of a key business process can be considered as critical data element.
Data element and critical data element are fundamental concepts in data management.
Now, knowing what the data element is, let's focus on the big picture of the metadata management capability.
By definition, metadata management involves managing data about other data, whereby this other data is generally referred to data models and structures, not the content. It includes managing information about data structures from different models and their mutual associations. For instance, metadata management includes information about business terms in glossary, attributes in logical data model, or tables and columns in the database, as well as their associations. So, if we put critical data element as a center of metadata universe, let's see what kind of data we can collect about it. We will start with business glossary, which contains business term which represents critical data element, then its definition, and synonyms and acronyms in use. In addition, we collect information about taxonomies, also called classifications, which actually determine how elements should be classified according to specific criteria. For instance, if the criteria is gender, person can be classified as male or female. Business rules refers to set of rules applicable to data element. Ownership refers to specific people or roles that are accountable or responsible for the data element. Logical data model refers to entities and attributes that are mapped to data element. Physical data refers to database schemas, tables and fields. Physical data are spread across several layers, like operational sources, data warehouse, analytical data marts and so on. In addition, there is an integration process between those layers, which refers to data movement from source to target data. Finally, there are various applications for reporting and analytics.
So, to summarize, with metadata management we are collecting information about critical data element, in order to understand how the data element is used across the organization. Once again, metadata management it is not about the actual data, but about the data models and structures. As an analogy, if we take an example of water supply, metadata is not about the water, in our case data, but about the infrastructure and pipes, in our case the data models and structures. The metadata information about glossaries, taxonomies, business rules and ownership are also called business metadata. On the other hand, the metadata information about logical data model, physical data and data integration are also called technical metadata. Business metadata describes data element from the business uses perspective, and includes information like business glossaries with terms and definitions, synonyms, acronyms, taxonomies, business rules, and ownership. Let's move forward with an example that covers business metadata.
Let's say we have data element named customer name, and the element is tagged as critical. Please note that, going forward, we would use the acronym CDE for critical data element. So, let's collect business metadata for customer name CDE, starting with the glossary part. Business term. The business term, used to represent that data element, is customer name. Definition. Customer name represents a word, or a combination of words, by which a customer is called or known. Customer refers to person or entity. Synonyms. Customer is often called as client, so, the client name could be the synonym for customer name. Taxonomies. Customer name can be referred in two contexts: as a legal name, or trade name. The legal name of a business is the name of the person or entity that owns a business. Legal name is the name that identifies a customer for legal, administrative and other official purposes. A trade name is generally considered as the name a business uses for advertising and sales purposes, that is different from the legal name in its articles of incorporation or other organizing documents. A trade name can also be referred to as a fictitious name or a doing business as. Examples of trade name is the use of the name McDonald's by the company whose legal name is McDonald's Corporation.
With business term, definition, synonyms, acronyms and taxonomies, we have covered the glossary part of the business metadata. The next piece of business metadata is about the business rules. On the screen you can see a set of business rules associated with our CDE, name customer name. For example, we have two rules that provide conformity of the legal customer name. The rules are defined as 1. For limited liability companies, LLCs, and corporations, the business legal name is the one that was registered with the state government. These names will often have a legal ending such as LLC, Inc. or LLP. And 2. If the business is a partnership, the legal name is the name given in the partnership agreement or the last names of the partners.
Also, we have one rule for trade name conformity, defined as: a trade name may not include Inc., LLC, Corp., or similar legal endings. Although a trade name may sometimes also be a trademark, a trade name is not in itself a form of intellectual property.
At this point, please remember that business rules are instrumental for data quality assessment, which is a part of data quality management capability. Data quality capability is covered in one of the lessons that follows. Before we move forward with our example of collecting metadata information for customer name CDE, let's discuss about roles and responsibilities related to metadata management capability.
In order to manage critical data elements on an effective way, we need to define and assign certain roles and also responsibilities for managing the CDE metadata. So here is the description of the roles and responsibilities.
Business owner is ultimately accountable with regard to the definition, data quality, and value of data in a given subject area. The business owner is responsible for confirming that data is used in a fashion consistent with the overall data strategy. Business owner is also responsible for driving data management processes and activities. Data steward is responsible for operational oversight of assigned data and interactions with subject matter experts, also called SMEs, across the organization, as well as identifying the approach to standardize, measure and monitor data quality. Charged with confirming that data standards are defined, processes are employed, and practices are implemented.
Technical owner is technology specialist who is ultimately accountable that data from particular data system are managed and used according to defined data standards. That includes enforcement of business rules, data policies, and procedures. Data custodian is technology specialist who is responsible for the secure storage and management of the data for the particular data system. Charged with confirming that the defined data standards are enforced.
Please note that business owner and data steward are business roles and need to be assigned among business professionals from the organization. On the other hand, technical owner and data custodian are technical roles and need to be assigned among technical professionals. Now, let's get back to our customer name CDE example. On the screen is shown customer name as critical data element. We have assigned metadata roles to particular people from the organization. Along with their names, there are information about their position, as well as contact information. Contact information is important, so that anybody can reach out to them in case of need for specific information, or to submit requests related to customer name CDE.
other than role assignment, please notice that some roles are exclusive, such as, for example, business owner. That ensures that certain aspects of critical data element, such as name or definition, have to be managed by one person in order to avoid ambiguity. On the other side, some roles, like data custodian, can be assigned to multiple people. By definition, data custodian is responsible to enforce standards for critical data element, in this case customer name CDE, for a particular system. Accordingly, if customer name has multiple representations across several data systems, the data custodian role will be assigned for each system.
Before we move forward, please note that metadata roles and responsibilities cover people aspect of metadata management capability, as we defined in course objectives.
So far, we have covered business metadata like glossary, business rules, and ownership. Now, it's time to look at technical metadata. Technical metadata describes data element from the technical user perspective, and includes information like logical data models, source and target systems, table and field structures, as well as cross-model dependencies. Besides business and technical metadata, there is another category, named operational metadata. Operational metadata includes information about application runs, their frequency, recorded counts, and other statistics for auditing purposes. Operational metadata is important for auditing purposes and technical operations. Now, let's get to the first example of technical metadata. One shown on the screen is specifically related to logical data model. Logical data model, or LDM metadata, refers to the information about entities, attributes, and their mutual relationships. After collecting metadata about logical data model, it is important to establish association between the CDE and all representations of CDE in logical data model. On that way you will be able to trace CDE lineage from business to technology. Let's look at an example with our customer name CDE. Let's say we have model with two entities, customer and order. Customer entity contains attributes such as customer ID, customer name, customer address, and so on. Therefore, we can make association between CDE customer name, which belongs to business metadata, and attribute customer name from the entity customer, which belongs to technical metadata.
Here is another example of technical metadata, this time with physical data model and data lineage. Physical model metadata includes information about data systems, database schemas, tables, columns, constraints, transformations, and so on. Also, it is important to establish association between CDE and all representations of CDE and physical data model, as well as to collect information about data lineage. Data lineage refers to traceable path for CDE, starting from end-user reports, upstream to the ultimate source. That path includes aggregated sources, such as data warehouse and data marts, operational data stores, staging areas, and transactional systems. Let's look at the example.
Let's say we have orders transactional system with two tables, CST representing the customer data and ORD representing the orders data. In addition, we have finance data mart, which contains aggregated information from order system. Aggregated information refers to the revenue, field amount, per customer, field CST ID, CSTNM, and per period of time, field PRDTP. Then, we perform data integration process, which aggregates data from orders transactional system into finance data mart. From the metadata perspective, we collect information about both systems, transactional and data mart, including tables and columns. As a last step, we make association between customer name CDE and its representations in both systems. For orders transactional system, that is column CSTNM in table CST. For finance data mart, that is column CSTNM in table FIN. Please note that, with these associations, you are able to trace CDE data flow, starting from business reports, trough data marts, transactional systems, upstream, to the ultimate source. That is what data lineage is about.
Now, we are getting to the point. By collecting CDE business metadata, such as definition, taxonomy, rules, then determining ownership, and finally collect technical metadata, such as data systems, tables, columns, and data lineage, you are getting complete view of CDE in the enterprise, also called CDE data standard.
Business and technical metadata together represents CDE data standard, which means that critical data element is completely described from business and technical perspective. CDE data standard is also called 360 view of CDE.
By achieving 360 view of your CDEs, you provide conditions for managed data environment, which is ultimate goal of data management. Once you achieve that, you will be able to answer questions such as:
what is the CDE definition? Who is business owner of the CDE? Where CDE data are stored? What reports uses CDE? What system is ultimate source of the CDE? And so on.
So far we discussed what kind of metadata we should collect about the CDEs. Now, let's formalize the process how to perform metadata collection and to enforce of CDE data standards across the organization.
The metadata management consists of 5 key activities. 1. Identify critical data elements. Refers to activities performed to analyze business requirements, conduct interviews with business stakeholders, and identify in scope CDEs. This activity is performed by business owner and data steward. 2. Collect CDE business metadata. For in-scope CDEs, define business term, synonyms, acronyms, definition, and taxonomies. Also, define business rules and determine ownership. This activity is also performed by business owner and data steward. 3. Collect CDE technical metadata. For in-scope CDEs, identify CDE representations in data systems, determine authoritative data source, and data lineage. Also, determine associations with logical data models, if exist. This activity is also performed by technical owner and data custodian. 4. Create CDE data standard, also called 360 view. Create associations between CDE business and technical metadata. Validate CDE data standard. This activity is performed by all metadata roles, business and technical. 5. Enforce CDE data standard. Enforce CDE data standard to ensure that every CDE is managed and used according to defined standard. This activity is colored differently because data standard enforcement spreads across metadata management and data governance capabilities. This activity is also performed by all metadata roles, business and technical.
Last but not least, brief reminder about our course objective to cover each capability from people, process and technology perspective. This slide refers to the process part. There is one more important aspect related to metadata management process. System Development Life Cycle, or SDLC. SDLC, or System Development Life Cycle, refers to the process of planning, creating, testing, and deploying of an information system. Metadata management process should be a part of SDLC. In other words, during application design and development, you should ensure enforcement of data standards defined as a part of metadata capability in all application segments.
Similar like previous slide, this slide refers to the process part of metadata management capability.
So far, we have covered metadata management fundamental concepts, as well as people and process aspects. Now, let's focus on the technology required to support metadata management process.
In order to establish metadata management capability, you need some tool to support the metadata process from technology perspective. Metadata management tool should have certain set of features in order to support metadata process on an effective way. Here is the list of some of the key features. 1. Ability to establish and deploy centralized metadata repository. 2. Ability to define consistent terms, valid definitions, valid values, data domains through a hierarchy of glossaries. 3. Ability to extract metadata from the popular database management systems, data modeling tools, business intelligence tools and ETL. 4. Ability to create, name and define associations between metadata repository artifacts. And 5. Ability to manage versions of metadata from multiple source tools and technologies.
Before we move forward, a brief reminder about the course objective to cover each capability from people, process and technology perspective. This slide refers to the technology part. Hope this journey through metadata management capability is getting you on the board for remaining capabilities. So far, we covered fundamental concepts, as well as people, process and technology aspects of metadata management.
Before we move to the next capability, here are the key takeaways. Critical data elements, also called CDEs, are foundational components of metadata management. Business metadata describes CDEs from business perspective and includes term, definition, synonyms, acronyms, business rules, taxonomies and ownership. Technical metadata describes CDEs from technology perspective. Includes logical data models, physical data models, data integration and data lineage. Metadata management process formalizes activities related to metadata management. Metadata management roles defines roles and responsibilities in metadata management process. Includes business owner, data steward, technical owner and data custodian. Data standards, also called 360 view, provides comprehensive view of CDEs, including business and technical metadata. and metadata management tools provide technology support to metadata management process in order to ensure that CDEs are properly managed and used.
That's all for Lesson 1, and metadata management capability. Before we move forward with the next lesson, take some fun and complete the metadata management quiz.